going to Algebra 2, Section 6.2, Factoring Other Polynomials. So, a polynomial is completely factored when there's no more common terms, and when you've tried all of our factoring methods, and none of them are working anymore, because you've done everything you can. And then remember, factor out the GCF, or greatest common factor, first. Now in example 1, A, B, and C, we're supposed to factor these completely. Each of these have a GCF, and then another step on top of it. So example A, they all have a GCF of, 4, not 2, y squared. And we're left with y to the fourth minus 5y squared plus 6. Now because this is a trinomial, we want to make our x. And at the top of the x, you put a times c, which is 1 times 6. And the bottom, you put negative 5 to the b. 2 of the same sign multiply to a positive on top, so a negative 3 and a negative 2 do the trick to add up to 5 and multiply to 6. And because this is as a equal to 1, we can use our shortcut. So we have 4y squared for the GCF, and we do y squared. We have to do this sign, that exponent. I'll talk about why it's that exponent, minus 3, and y squared minus 2. I said I'd talk about why we would do the exponent of 2 there. Well, is if you were to take y squared times y squared and multiply it back out, you end up getting y to the fourth, if you add those exponents. Y squared times negative 2 is negative 2y squared. Negative 3 times y squared is negative 3y squared. And negative 3 times negative 2 is positive 6. And you notice if you combine those two terms in the middle, you end up getting exactly what we started with. If you went the long way, you would also notice that as you split up the middle into negative 3y squared and negative 2y squared, that you would have to end up having y squared minus 3 and y squared minus 2 as well. On letter B, the GCF is 2x to the third, and we're left with 25x squared minus 16. And this, two terms, we want to look for a difference of two squares, and we do have it, because 25x squared is a perfect square, and 16 is a perfect square, and we're subtracting them. So we put the GCF out in front, and the first parenthesis, we put the square root of the first, 5x, minus the square root of the second, and then we do the square root of the first plus the square root of the second. And which one of the parentheses has a plus or minus sign doesn't matter, as long as one has each of them. Letter C, we take out a GCF. This time, the GCF is 3m to the second, and we're left with m to the 10th, plus 18m to the 5th, plus 17. This one we also want to make the x on. This time, 17 times 1 is 17, and 18 on the bottom. Positive 17, positive 1 will do the trick. This has an a of 1, so we can do our shortcut, 3m squared. The variable is going to be m to the 5th, and the two sides are plus 17 and plus 1. And just like that first one, you notice we did the middle term's exponent in both of those, and that'll be the case each time with those. But you want to double check though that 10 is double 5, just like on the first one, 4 is double 2. Now we got some new factoring rules. Sum and difference of two cubes. So not just a difference of two squares, now we're talking about two different cubes. So a number times itself 3 times. So for example, a cubed plus b cubed. It could be any number, just calling it a variable for now. Our shortcut for this is going to be two different parentheses. One's going to be a binomial with 2 terms, and the other one's going to be a trinomial, so 3 terms. The binomial is a plus b. So whatever the actual number being cubed it would be is, and adding together. Then our other one is going to be the first number squared, a squared, minus the opposite sign, the two numbers times each other, plus the second one being squared. I want to note that these two, in the first parenthesis and the original, are the same sign, and compared to the original and the middle where that's a times b, the two numbers times each other, they are different signs. difference of two cubes will follow a similar pattern, where in our first parenthesis we're going to have a binomial, second parenthesis a trinomial. And we still do a and b, so the numbers, but this time we're going to do minus, because these still have the same sign, just like when we did the sum of two cubes. And then the difference of cubes, this trinomial is going to be very similar to the sum of two cubes trinomial, where it's the first number squared, but this time plus the two numbers times each other, and again plus the second number squared. So between these two, they flip-flop which sign, the plus sign and the minus sign. And both of them, the sign in the binomial, the first one, with the regular numbers, not the squared numbers, is the same sign we start with, whether it's sum or difference, plus or minus. And then in the trinomials, the first sign we see is the opposite sign from the start. So following this example, x cubed plus 27, this is a sum of two cubes, because x cubed is x times x times x, and 27 is 3 cubed, or 3 times 3 times 3. I find it helpful to write above the number or somewhere near there, hey, what is the cube root, or what is the number being cubed, or the variable being cubed there? So now we know we're going to have a binomial and a trinomial. And our binomial, we're going to do x, 3, and then we're going to put the same sign that was there, so x plus 3. And our trinomial, we're going to do the first one squared, so x squared. This time we're going to do the opposite sign, and we're going to do the two numbers times each other, so 3 times x, so 3x. And then the last term is going to be plus the second number squared, so 9. And then we factored it. For the next example, 8x cubed is 2x times 2x times 2x. And 125 is 5 times 5 times 5. And this time we're subtracting them, so it's the difference of two cubes. So we have a binomial and a trinomial again. The binomial will be the two numbers, 2x and 5, with the same sign as what we started with, minus. The trinomial will be the first one squared, so 2x times 2x is 4x squared. Opposite sign, so plus this time. The two numbers times each other, 2x times 5 is 10x. And then plus the second number squared, so 25 is 5 squared. So notice, whether it's the sum or difference of two cubes, the only thing that changes are the first sign and the second sign that we see. The first sign is always the same as what we start with, the second sign is always the opposite. Alright, so it can be very helpful to know your perfect cubes, but if you don't have them memorized, you can always find them by using a calculator as well. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1000. Factor this polynomial completely. So we have 16u to the fifth minus 250u squared. So first we have a GCF, and our GCF is 2u squared. And then we're left with 8u cubed minus 125. So, just like what we are practicing, we have a difference of two cubes to start. So 8u cubed is really 2u times 2u times 2u. Because 8 is 2 cubed, and u cubed is, well, u cubed. Then 125 is 5 cubed, so it's 5 times 5 times 5. So that's our difference of two cubes. So how we progress from there is we do the binomial and the trinomial. 2 terms and 3 terms. The binomial, sorry about that, rotation there, is the two numbers, 2u and 5, with the same sign that we started with, so minus. The trinomial is the first one squared, so 4u squared is 2u squared. And then the opposite sign we started with, so plus the 2 times each other, so 2u times 5 is 10u. And then plus the second squared, so 25 is 5 squared. And then we can't forget about this GCF here. So we put 2u squared out in front. And now we have it completely factored. Moving on. Example 3, factoring this completely. So, a little hint that sometimes writing it as this cubed or this cubed can be helpful. It's really the same thing I'm doing, where I'm writing it above there as x and 3, or 2x and 5, just adding in a cube if you want. Personally, I like writing it without the cubed, but if you prefer writing it with the cubed, you're more than welcome to. I encourage you to try any of these examples on your own by pausing the video and then continuing it on after you've tried it. So x is x cubed, or excuse me, x times x times x is x cubed, and 4 times 4 times 4 is 64. So sum of two cubes, binomial, trinomial. The first one's x plus 4. The second one is going to be x squared minus the opposite sign, 4 times x, so 4x, and then plus 16. Going on to letter B. Y cubed minus 27. Y times y times y is y cubed, and 3 times 3 times 3 is 27. This time, our binomial will be subtraction, because it starts out as subtraction. So we do y minus 3, 2 minus each other. Then we do the first one squared, opposite sign plus the 2 times each other, 3y, plus the second one squared, 9. Now on to C. 216x squared is 6x times 6x times 6x. 125 is 5 times 5 times 5. Also, I think I said squared a moment ago, but that's cubed. And so we have a difference of two cubes here. So binomial, trinomial. The binomial is going to be 6x minus 5. The 2 minus each other. Trinomial starts out as the first one squared, so 36x squared. Opposite sign plus. And then we do the 2 times each other, so 30x. Plus the second squared, 25. Letter D. 192y cubed plus 3. Now, you might be thinking, okay, wait, what times itself 3 times is 192? And then you might realize, wait, nothing times itself 3 times is 3. So that might lead us to believe, hey, try out a GCF. And 3 goes into both. So then if we take 3 out, we're going to be left with 64y cubed plus 1. Now, if you notice, 64 is 4 times 4 times 4. So it's really 4y times 4y times 4y to get the y cubed part as well. And then 1 cubed as well. 1 times 1 times 1 gives us 1. So that's also a perfect cube. So now we have a sum of two cubes. So we can do a binomial, a trinomial. And the first one is going to be 4y plus 1, the same y we started with, or same sign we started with. I said y. The second one is the first one squared, so 16y squared. Opposite sign, so minus, 2 times each other, so 4y, plus the second one squared, which is 1. And we can't forget the GCF out in front of 3. The next method we're going to quote-unquote learn, but I say quote-unquote because we've actually already learned it before, is factoring by grouping. So we're just kind of reviewing it. So we use it when a polynomial has 4 terms. And we've already done this because, well, we do it with trinomials when we go quote-unquote the long way, when a doesn't equal 1. So, quick step, hey, before you do anything else, actually make sure everything is on the same side. Make sure all terms on the same side. And what that means is, hey, in this example, x cubed minus 3x squared minus 16x plus 48, let's say it was equal to some number 5, well, you would first have to subtract 5 from both sides. Then you'd have to make sure it's equal to 0 in order to start. But we'll say for this example, it's already equal to 0. The first step is to group all the terms, and then I'm going to get rid of that last little part of that because we haven't been practicing it like that, so I don't want to throw a curveball into there now. It won't affect one way or the other what you do, so I'm just going to have us ignore it. So group the terms, so first two, second two, and I always say to include the sign with that third term. Then you factor a GCF from each group. So what's in common between x cubed and 3x squared? Well, x squared. And then we have x minus 3. And then negative 16x plus 48. Remember, we don't want it to start negative, so we take a negative out. And we take a 16 out. And we're left with x minus 3. And that would still equal 0. Now we notice that, hey, the insides match. And it does say what's left over should match. So one factor is the GCF of each, so x squared minus 16, and their factor is going to be the leftovers that were the same. So we're going to end up getting x minus 3 in one parenthesis, and x squared minus 16 in one parenthesis, and that equals 0. And then here, this one happens to have an extra step here by factoring it completely, and we're one step ahead because we just drew those parentheses where it was already written rather than in example 1. So if we would have rewrote the whole thing with just with the parentheses around it, for example, for step 1, then we would be using all 4 steps. But because we did that where it was already written for the example, we're really going to use 3 steps here, just so you know. So we're not going to use this step line, even though we are doing 4 steps. So the second one can be factored further because it's a difference of 2 squares. So we have the difference, and then we have x squared, which is x times x, 16, which is 4 times 4. So we do x minus 4 and x plus 4 in either order, and it would still equal 0, and now it's completely factored. And if you were asked to solve, you would set this equal to 0, this equal to 0, this equal to 0, and solve those 3 equations. But we're not asked to, so we won't. So quick recap, even though we've done this before, I want to still recap it, that you group the first two, group the last two, including that sign with a third term. Then you pull a GCF out of the first one, a GCF out of the second one. They should match if you're doing it correctly. Then those go in front together, and the leftovers, so to speak, go in the second parenthesis. And then sometimes you have to factor more with like a difference of 2 squares or something. All right, go ahead and try the examples 4, A, B, and C on your own if you would like. Heads up, B you can continue on, and C you can continue on, but not A. On letter A, we have the first two group, the second two group, the last two group, excuse me. And by the way, if there is a GCF to start, you always take one out, but there isn't on any of these. The first two have an x squared in common, and you're left with x plus 1. The second two just have a 1 in common, nothing else, so we take x plus 1 and put that in parentheses. Parentheses match, you put that in front and get x plus 1. Second set is the leftovers, x squared plus 1. And even though x squared and 1 are both perfect squares, we can't continue because there's addition, not subtraction. Letter B, we're going to group the first two together, last two together. First two have an n squared, and we're left with n plus 5. Second two start with a negative, so we take a negative out, and take a 9 out, so we're left with n plus 5. Notice that, hey, they're the same. So we end up getting n plus 5 out in front, and the other one's n squared minus 9. And I did say, hey, we can go farther because this one is a difference, and it's 2 different squares. So we do n plus 5, and then the square root of first minus the square root of second, n minus 3, and the square root of first plus the square root of second, really in either order, n plus 3. Now it's completely factored. So we move on to C. C, group the first two, last two. First one has 25h squared in common, and you're left with h minus 4. Second one has a negative 1 that we want to pull out because it starts out negative, and we don't want it to start out negative. And then we have h minus 4. So we pull the h minus 4 that's the same in the first parenthesis, and then we put 25h squared minus 1 in the second parenthesis. Notice that we can take the second one further because it's a difference of 2 squares. Because 5h times 5h is 25h squared, and 1 times 1 is 1. So you do h minus 4, and then the second one splits into 5h minus 1 and 5h plus 1, and those parentheses are interchangeable. That is it for section 6.2 today.